Hi friends, just a quick one here. For today we have the summation from n equals to 0 to infinity of cos to the power 2n of theta equals 5, and we want to find the value of cosine of 2 theta. Alright, let's get started. So the summation from n equals to 0 to infinity of cos to the power 2n of theta. Let's just write out the first few terms of this summation. So for n equals to 0, that's cos to the power 0, which is just a 1. For n equals to 1, we'll have cos 2 times 1 is 2, so that's just cos squared. For n equals 2, that's cos to the power 4 theta, and the trend goes on up to infinity. So if you look at this here, this is a geometric series or a geometric progression. So this is a geometric progression, and we can actually state some of its defining characteristics, like the first term. So the first term of this geometric progression, we usually call that A. So the first term is 1, there you go. And the common ratio, which is like the factor that you multiply in moving from one term to the next. So clearly from here you can see that the common ratio is cos squared theta. We usually call the common ratio R. So R is cos squared theta. From 1 to this, you can see there is a multiple of cos squared theta. From here to here, we multiplied by cos squared theta, and this is going on up to infinity. Okay, just remove this. Oh, what am I doing? So this is cos squared theta. So we can actually find the sum to infinity of a geometric progression, and the sum to infinity is given by the first term. Let's call that A divided by 1 minus R. 1 minus R because if we are finding the sum to infinity, obviously R is less than 1, so the sum converges, which is true in this case. So let's go ahead and find that sum to infinity for this progression here. Geometric progression, the first term is A, which is 1, divided by 1 minus R, that's 1 minus cos squared theta. But we actually know that sine squared theta plus cos squared theta is a 1, which means 1 minus cos squared theta is actually sine squared theta. So what does this imply? It means our sum to infinity is just 1 over sine squared theta. And remember, all this here is, all this is actually equal to 5. So I'll just equate this to 5. So let's go ahead and solve this now. So we have 1, maybe another color here. Okay, so 1 out of sine squared theta equals 5. This is as well, you can say sine squared theta equals 1 out of 5. Okay, so there's a relationship between sine squared theta and cos 2 theta, which is what we want to find. So let's go ahead and do that. So I'll just derive this from first principles. Cos 2 theta is cos squared theta minus sine squared theta. So cos 2 theta. So let's see, I have sine squared theta, which I want to get rid of. Okay, so I'll substitute for cos squared, which is 1 minus sine squared theta minus sine squared theta. So you have cos 2 theta as 1 minus 2 sine squared theta. And let's just come this side. So from here, we'll have sine squared theta. Sine squared theta is going to be 1 plus, is that? No, 1 minus cos 2 theta. And then there is a factor of 1/2. So I'll get this. I put it here. So just get another color, 1/2. of 1 minus cos 2 theta equals 1 out of 5. So just more space down here. 1 minus cosine of 2 theta is 2 over 5. I multiply both sides by 2, and then cosine of 2 theta is 2 over 5. What's that going to be? Oops, no, that's 1 minus 2 over 5, which is 3 out of 5. So that's our solution. Cosine of 2 theta is 3 over 5. So thanks for watching this. If you find it helpful, give me a thumbs up, subscribe to the channel if you haven't subscribed yet. I'll see you in my next problem. Bye.